kind of went up. I got a job at Zoox, which is a much more mature and increasingly successful robo-taxi company. So I got to work there for a couple years. It was an awesome experience. And then some other considerations came up and decided I would like to make the hop across the pond to Sweden. And now I work at Scania, which is a trucking company, and they have some autonomous trucking ventures. So throughout all of these positions, I've been involved in some way, shape, or form with planning and controls, whether it's actually writing vehicle code or evaluating the vehicle code off board. So now getting into things that might be important for you. So the first question that I want to have in your minds is, what do you want? And so the first thing is the big split between, do you want to go into industry or do you want to go into academia? I'm coming at things from the industrial perspective, so I'm just going to give you the pros of why industry might be something you like. And I'm sure the rest of our speakers can give you the academic side and give you the pros of why you might want to go into academia. There's definitely pros and cons to both. But looking at industry, the first thing that sticks out is product driven, which means you get to work on something real almost all the time. So your companies are completely driven by making something that's going to make money, and that's usually either a physical product like some sort of robot, manufacturing equipment, or a service that enables things that do something in the real world. So that's the first thing. You get to work on something quote unquote real. The second thing is the job supply is super plentiful and diverse, especially when compared to academia, unfortunately. It's just the way the world works. There's more jobs out there in industry than academia. And the third thing is generally the salary and benefits are great. They start at great and they go to spectacular. So yeah, it's pretty nice. So a big disclaimer that I also want you to know is in industry, and probably in academia too, you will almost never use exactly what your thesis work is about. This definitely was true for me. I have not used what I worked on in my dissertation exactly, like once in my professional career, but that's okay. And the reason that it's okay, the reason why you should still pursue your graduate degree is companies really want to hire grad degree holders. They have extreme incentives to do so. And the reason is it's a strong, if imperfect, proxy for many desired traits that businesses want out of their employees. One is it means you can learn new things quickly. Two, it means you can solve really complicated problems. And three is it means you know how to communicate effectively through writing, at least, and often through other forms. So yeah, those things, they all serve really well in the workplace, and you develop those skills when you go through the process of writing a thesis or a dissertation and doing original research. So yeah, totally worth. Do your grad degree, start to finish, do a good job, do the very best job you can, and you'll have a much better time getting a job for it. Another thing I want to clear up before I keep going is you may have noticed already I'm talking about planning and control. These two things get lumped together a lot in industry, and it's for a good reason, in my opinion, which is that they're basically the same. I kind of put a diagram to explain why I claim that they're the same. I'm not going to go through it right now, but just know that for me, they're basically the same. You may see job titles like listed with them differently, but largely the techniques are the same. A lot of it just comes down to philosophical differences. And I say this so that if you think of yourself as a control person, you don't limit yourself to just the roles that say controls on them. But you also think of yourself as a planning person, because many of the planning jobs are actually using techniques from what is considered control in academia, and vice versa. If you consider yourself a motion planning person or path planning of any kind person, you may also enjoy doing a controls job. So kind of going along this theme of casting a wide net, which goes into what do you want, my goal with these slides is to get you to think outside maybe of your current perspective of what kind of industrial job might you enjoy or like. So the first avenue that you can expand on to cast a wide net is roles. So consider roles whose title or job description goes beyond your original expectations. I wrote a bunch out here. I'm not just going to list them out verbatim, but I put them all here so that you have some like keywords to hit on when you're doing your searches and things that you can have in your brain as this is actually possibly a great fit for me. It might actually fit my training really well. So stuff that's really technical, you know, it might literally say controls engineer, where it's sort of like, yeah, that's what I was looking for. But it might not. You know, simulation engineers also use controls. Optimization engineers get tapped for doing controls work. And then there's a lot of roles that can benefit from controls knowledge that aren't directly like writing control algorithms to run on a robot in real time. From the data science stuff to machine learning, research of various kinds. And then broadening out even more, there's these like so-called agile development roles that are maybe a little less technical, but they're about making the technical teams more efficient and more productive. And often the people that are in these roles have a very technical background and often have a master's or a PhD. So don't rule those out just because you think they're beneath you or wouldn't benefit from your theoretical training. If there's something that interests you, if you're interested in managing products, working with other engineers, being a bit more people focused, it could be a really good job for you. And they also happen to pay pretty well, usually as well as the technical jobs. Another way you can cast a wide net is industries. There are a ton of industries out there that use planning and control roles in some way or another. I just listed 16 out here. There's plenty more. You can Google and ChatGPT to find all the industries that possibly exist. But yeah, don't limit yourself to just one industry. Like, you know, even though I've been in the like robo-taxi / autonomous driving industry so far, I wouldn't limit myself to that in my job search at all. I haven't done that. And there's tons of jobs out there. Robotics shows up in practically every industry these days because people want to automate everything. So yeah, just the world is your oyster. Look for all the industries you can. And then the last way you can broaden your search is countries, geographically. So contrary to what you might hear, the USA is not the only country with awesome jobs, although there are a lot of awesome jobs in the US. Consider opportunities abroad. And you can use a lot of web resources to help inform your search. I listed an app, which I actually coded myself. It actually was one of the key parts of my decision to move to Sweden from the United States. So, you know, I'm eating my own cooking with that. So yeah, check it out and see if there's other countries that might fit your lifestyle and have jobs that are interesting to you. Okay, so we got through all of that. Say you do want a job. You want a job in industry. You've made that sort of decision, or at least you want to look into it. So what do you need to do to get that job? So the first thing is hone your skills. So yeah, there's no way around it. If you want a job in planning controls, you need to be skilled technically. And these days, that really means software. Most of your job is going to be writing software. It'll usually be supported by some amount of mathematics and research and, you know, writing stuff out on whiteboards and thinking about it. But at the end of the day, all of your work is going to be implemented in code. So that means you need to get familiar with the workhorse algorithms that are relevant to planning and control, and also that are relevant to the places where planning and control interfaces with other components in autonomous driving stacks or other robotic stacks or whatever it is. So that usually means like machine learning algorithms, maybe like prediction algorithms, possibly even perception vision algorithms. That's all going to be very useful and maybe even required depending on your role. So the best way to do that is just implement these things from scratch. And luckily, the workhorse algorithms are also very simple to implement usually, and usually simple to understand. Luckily, and this is something we're often not used to in grad school, the simplest solutions are the best solutions. You definitely want to use the simpler algorithms when they will get the job done. Not just because they're easier for you to understand, but they're easier for your peers to understand, the people that are reviewing your code and signing off on things. And they're also usually simpler for computers to understand, meaning it takes less lines of code to implement them, and oftentimes less computational work to actually run them. So that's one thing. And I have a bunch of these algorithms listed in the bonus slides. There's like a ton of bonus slides in this PDF that I think will get shared out by the end of this workshop. So you can dig through all of the stuff that I just can't run through right now. You need to speak two modern programming languages at least, and Python and C++ is the most popular combo by far. Everyone uses them. It's just kind of how it is. Python for prototyping and C++ for real-time and performant code operation. There's other good languages as well. You know, there's modern ones like Rust and Go. MATLAB is definitely used for prototyping and some things, but it's definitely not the preference, I would say. You need to, unfortunately, you do need to grind a little bit on coding problems using platforms like LeetCode and HackerRank. Companies love to use these to suss out if you actually know how to implement algorithms and reason about problems, very simple problems, you know, in more or less real time. And the other thing that will help is if you learn the mechanics of how to develop software. You might hear this called DevOps. So this is kind of like just how you write code and how you actually go about like creating the software. So these are tools like Git and GitHub for version control, continuous integration, continuous deployment tools, cloud computing platforms, AWS, Google Cloud Platform, Azure, and then some other things that are more about how you design your software, like APIs and design patterns. That'll give you a real edge when it comes to looking professional and appearing that you actually know how to write software that's ready for production environment. So once you've honed your skills, the next thing that's going to make you really shine is if you showcase your talent by building a portfolio of your coolest work. You want to show and not just tell about how talented you are. So ways you can do that, you can play with the robotics data sets and challenges that are out there. I've listed a bunch of these in the bonus slides. And then when you're done, you can create a website where people can actually click through and watch videos or actually play with live demo code that you've written. And I put up my personal website that has some examples on how to do that. And that's something you can list right at the top of your resume, and people are going to love to click on that and see the cool stuff you've worked on. And there's some modern Python frameworks that make it easy to do that. And then the last thing is you got to create your resume. There's a lot of good practices for how to do that. I would say just Google it. It's super well trodden. Most of the advice from the tech industry will apply. I put one link here that you can look at. And I also attached my own resume that got me the current job that I have in the bonus slides if you just want a rough guide on how to structure it and lay it out. One thing I'll point out, just because I didn't used to know this, LaTeX is really a risk. It can mangle automated resume checking systems, and it's just more trouble than it's worth, honestly. So just use Microsoft Word or Google Docs, something that's really easy, like a very simple markup with enough flexibility to do good formatting and make it look presentable. I'm sure something you're maybe hesitant about is applying online. And I'll say it can work. I have to say it can work because of the 3 jobs I've had so far in the autonomous driving industry. I've gotten all 3 of them by applying online, just cold calling. But it is very hard. I will say it's very hard. It's not like you're just going to apply to the 5 roles that you like the best and you're going to get callbacks on all 5. The per application success rate is very low, like probably in the single digits of percentage points. So it's a numbers game at the end of the day. You have to be patient and persistent, and you'll probably send out more than 100 applications before you're done. I know I did. I'll say you often get the best results when you apply directly to the companies using their career websites. So an effective technique is to just find all of the companies that you can that are relevant to the industry, the role, the kind of work you're interested in that might have planning and control stuff open. Just search them on Google, find their careers page, and then search through their career page to find anything that's remotely a good match for you, and then go from there and do the applications. Other tips is to know your market. You'll maximize your chances if you apply during the peak hiring periods. So certain times of the week are better because people tend to put postings up at that time, and if you get your foot in first, you'll generally have a better chance. And the same thing seasonally. Some seasons in certain countries are just really dead or really lively. So yeah, just check the internet, Reddit, Google search to figure out when those peak hiring periods are. If you care about the role, which hopefully you care about all the roles that you're spending time applying for, write a cover letter. Even if it doesn't say you have to, it will just make you stand out and look like you really care about it. And personalize it, explain why you're a good fit, how your prior experience and projects fit into the role, to help the hiring manager see how you would be fitting into this position. And tailor your resume and the cover letter for each application. Let's see. Networking can be intimidating, especially for introverts. Just remember, many people on the other side of the table are also introverts. So your goal is to create small, defined, low-stakes connections that feel natural. So good formats are, if you go, you can take a short walk near their office, or even just sit at a table outside of their office to make it easy for them. If you go to a nearby coffee shop or a cafe or just a casual third space, that's usually going to help calm nerves and make it feel casual and not high stakes. And if you set a short defined duration, 15 or 30 minutes, that will also ease tensions because then both sides know they can get out and it won't be awkward for too long. And of course, if things are going well and you're chatting up a storm, you can keep going if there's time, but always make sure there's a way out. I can't advocate this enough. Do mock interviews. The best way to prep is pretend like you're in an interview. And using your peers is usually the best way because they're the closest to knowing what kind of material, technical material, your interviewers might be asking you about. So you can check out these online guides on how to do this. There's even commercial companies that offer mock interview services. I've never used those, probably not necessary, but you can look into that as well. And I put a basic workflow in the bonus slides. Okay, so coming to the last section, I will wrap up in 2 minutes so we can get a little bit of Q&A in. So say you land a job offer, everything went well. This may feel presumptuous right now if you don't have a job offer, but you can always come back to this later if you do get an offer. Before you accept, it's good to evaluate and possibly negotiate your offer. It basically never hurts to ask for higher salary and or better benefits. And if you're working with a recruiter, they're incentivized to get you the best deal. So you should definitely ask. But it is a negotiation at the end of the day, and you need some leverage to get a better deal. The best thing you can have, obviously, is an offer from a competing company, specifically in the same industry. So if they're like a direct competitor of each other, then you can really use that to get the salary up to an extent. And the other thing that can help is if you know the market rates for your role, which honestly, this usually is never an issue. Companies are generally going to give you market rates, but it's good to know what these levels are to make sure you're not getting shortchanged, like you're not way below the median or something. And so lastly, the last thing I want to plug is even though we're working really hard in our research and in our jobs and trying to solve the most hard to tackle problems in the world, we need to keep our work in perspective. So at the end of the day, not everything is about work. Advocate for yourself. Burnout is real and you need to take steps to prevent it. There's no medal for working yourself to death, and your career is going to be a marathon over decades and not a sprint. Give yourself permission to rest and to play. Look out for your mental health and make time for your hobbies. And at the same time, advocate for other people who aren't yourself. Make time for your loved ones and consider the impact of your work and your company on the community, on the people around the world, and on the environment. And sort of related to that, I'll just give a plug real quick. This is November, which means it's Movember. You may have noticed I'm sporting this mustache. It's not just so I can look handsome. It's to raise awareness for men's health issues, mainly mental health and cancer treatment. So check out the link at Movember if you're interested in those efforts. And if you can grow a mustache, maybe consider helping raise awareness for that too. Okay, cool. We'll move to the Q&A section. I know I may have ran over a couple minutes, but yeah, I'll just leave it paused there and open up the floor for questions.
Hopefully Ben can hear us. Can you hear us? Yes, I hope so. There were lots of claps. Yes. So questions. If there's someone online, I guess raise your hand, and then in person, anyone have any questions for Ben or Dr. Rao? A lot of blank faces as always, which I presume you know when you have a large audience, it sort of just stands there like that. We do have a list of questions from people ahead of time. If you want to hand us some of those. It's a very long list.
But I'd actually ask a question.
Okay. You want to ask a question?
Yeah.
Yeah.
Hey, Ben.
Camera's right there.
Oh, yeah. So you said that you're probably going to submit 100 or maybe more applications, and then you have to tailor your resume and cover letter for all of them, which can be, I'm sure you can assume that time consuming. So how long do you expect a good return offer on all the time that you spent on those resume applications?
Yeah, that's a great question. And maybe I didn't represent that quite realistically. I don't think it's feasible to tailor 100 resumes and cover letters. That would be a lot. So realistically, you'll probably, like just speaking from personal experience with the last couple times I've done this, you'll probably do personalized apps for at least like 20 or 30. It is time consuming, like to be honest, it's time consuming. And then, the rest of the 60, 70, 80, especially if there are roles where you just cannot submit a cover letter, that's sort of in your favor because you don't have to waste your time on it. That's where the rest of it will be coming from. So yeah, I guess it's sort of, and in terms of tailoring resumes, I generally tailor them maybe to like, a couple different levels of granularity. Like, there might be a resume that starts as like, this is like for controls positions. So it's like all like the experience that's relevant to controls and algorithmic design. And then I only have to tweak a few things to personalize it to the company. So if you sort of organize things like that, that can save you some time when you're generating these things. But yeah, I'd say like the raw quantity probably will be at least 100.
Well, I'm going to go grab the list of questions unless anyone else wants to have one for in person or online. We don't have hands up. That's I don't know. Can we rotate it to show Ben how many people showed up? I think it's a pretty good crowd. We got like 20-ish, 20. I'm bad at counting numbers. I think it's a lot of students, personally.
If you can stick around for like maybe 40-50 more minutes, I can send you the list of questions and you can go through them and then figure out which ones you can answer best. That sounds right.
That is if you want to stay around for the other speakers.
Yeah, I probably can't stick around. Unfortunately, it's 10:30 p.m. at night here in Sweden. But I'm happy to take the list of questions that's been prepared and write quick responses to as many as I can, maybe tomorrow morning or something.
Thank you very much. Okay, well, do we have questions? Any more questions for Ben before going to bed? It's a very late time. Thank you for joining us. I'm planning on going into academia, so like I don't have that many questions for you. It's kind of a different field, but there's definitely some feedback that you gave that I assume is very similar. Okay, so thank you, Ben. Moving on, I guess. Okay, well, we'll move over to the other one. We had Ben there. I get to introduce our next speaker, Dr. Wang. You're the assistant prof here. You just came this semester, right?
Yes.
I'll let you do all of the fun stuff, but you're our recent hire who knows the academia from a now perspective a little bit more as well.
Thank you very much.
So thank you. Yes. You wanna open up the slidey slide, whatever the this button there. I think that's right. We good?
Oh,
You
yeah.
want the
Sure.
teams? You want to share in teams?
Yeah, it's possible.
We didn't present in teams.
Sure.
There.
Yes.
Sure. Present. There we go. Interesting. There, pop out one, I guess. Here, I got an approach. We're gonna cancel on this guy. And we're gonna do the
Good.
And then hopefully that's visible. Oh yeah. Cool.
Okay.
Thank you.
Very much. So this is the microphone. Okay. Yes. Good. Thank you. Understand. Sure. So thank you very much. Thank you, Sesi, for inviting me to give this I would say highly personalized presentation. So all I want to present is 100% of my personal opinion. It may not be true at all. So we have been just give us a very spectacular presentation of finding a job in academia. And today I will change gear to illustrate a little bit more on the other side of the world. So my first question: any of you are PhD students? Please raise up your hand. Okay, we have quite several. So any of you are considering to do a no industry related job? Very few. Okay, good. But I mean, some of you may still, be interested in finding some other opportunities. So basically, after PhD, there are two options: go to industry or academia. But the question is that, in addition to the two most common options, we have something in between. It's not working. So we have something in between called National Lab. So any of you who has never heard about National Lab before? Okay, good. Okay. So basically today I will focus on the right two options, National Lab and academia. Okay, so let me first introduce about the procedure of academia job hunting, because I did this, just several months ago. I still remember something. So step one, just like a industry job, we need to identify the suitable positions. It depends on different university types and many other factors beyond our control. You can find, different faculty jobs appear online from August, maybe to November, or even sometimes it appears from the next year's, February, etc. It can be very late, but I mean, so most of the academia job will appear online after August. That means new semester starts. And there are several, common websites or tools you can leverage, to help you identify this kind of academia job. So Indeed, Hire ED Jobs, and the university's website. And the last one is LinkedIn. Actually, I do not recommend LinkedIn if you are looking for academia job. So the first three will be the major sources of information for you guys. After you identify the suitable positions, then we need to submit documents online. And compared to industry, so academia job requires to prepare a lot of other documents. For example,
those are the required documents. I just do a copy from one job right now. Still waiting for application from UT Dallas. So we need to have a cover letter, teaching philosophy, CV, research statement. And some universities also require you to submit a diversity, equity, and inclusive statement. And of course, you need to provide reference letters. But for the reference letter, it can be tricky. Some universities require you to upload the letter immediately when you apply. Some others will ask the letters when you pass the first or even the second round of interviews. Okay. And after you submitted documents, then it will be a Zoom or Teams interviews. This kind of Zoom or Teams interview will begin in November, December, January, February, basically anytime before the start of the new semester in fall. And actually, if you reach this step, congratulations, you are already, I would say, top 10, over 100 candidates or 100 applicants. So as Ben just mentioned, actually, finding an academic job is much difficult compared to industry because the positions are just very limited. Okay, so you did a great job doing your Zoom or Teams interview. Then it will be the last step for on-site interview. On-site interview basically starts, at the beginning of the spring semester. And if you reach this step, big congratulations, you are already the top 3 candidates. Okay. And then how about the Zoom interview? Anything I want to share specifically here? So during the Zoom interview, they may ask a lot of, I would say, quite standard questions. Why our school? Why do you fit this position? Your experiences and plan in terms of teaching, research, DEI, funding, etc., etc. How do you collaborate with the existing faculties in the departments? How do you contribute? Any equipment you will purchase, and of course, you have the freedom to ask your own questions. And the period of this kind of academic job hunting, a period of this kind of Zoom interview can last from 10 minutes to 20 minutes to 30 minutes. It's really changed a lot. And the format of this Zoom interview, it includes pure talk. You can present a 5-minute slides, 10-minute slides, 15-minute slides. Myself, I went through all those different formats by myself. So do not, you have the freedom to ask the search committee which kind of specific formats they will, ask you to do. And for the team interview, or for the Teams or Zoom interview, so several tips. Of course, for the majority of the questions, there are a repetition of your documents. So you need to be very familiar with all the documents you submitted. And I also agree with Ben that you need to do quite good mock interviews, because the question of this kind of Zoom interview is that you need to answer your questions. You need to deliver sufficient information within very limited time. And it also makes more sense if you know your interviewers and make sure to be relaxed during this kind of very short time. Okay, after the Zoom interview, how about the on-site interview? On-site interview, I will directly share this, calendar that UT Dallas sent to me. So basically, it all starts from a breakfast. Good. And in this specific day, you will have a lot of, one-on-one interviews with individual faculty members. And the big thing is here, you will deliver a seminar in front of many audiences, including students, faculty members. They are not always, from the same department where you are applying for, but also include, some other students, faculty members from other departments who may be interested in your research. Okay, and you will, in addition to breakfast, you will also be offered a lunch and a dinner. So that's a very good bonus. Okay, some tips. So of course, seminar, I would say seminar is, in my opinion, most important part of your interview, on-site interview. So practice your seminar, as many times as you can before you do the on-site interview. And of course, since you will have a lot of one-on-one, is kind of a call interviews, you need to know who will interview you before coming on site. And since you need to have a lot of, time spent together with your future, colleagues, maybe for the following 10, 20, even 30 years, please make sure be polite, but also be yourself. Okay, so those are academia job, hunting side. I want to mention a little bit today. And I think one specific question people ask me to illustrate is how to be a competitive candidate. So first, good publication for sure. Good communication skills. Strong recommendation letters. Proposal writing expenses and funding records. I know for PhD students, this proposal writing expenses and funding records are not that common. But the question is that nowadays, the academia job market is so competitive. If you have this kind of, expenses, that will help you a lot. And you need to have an exciting and complementary research plan. So I want to emphasize that the research plan should be complementary. If what you propose to do has a very large overlapping with some, ongoing research, within that specific departments, I would say this will be a big no-no. And in addition to that, if you have some kind of industry or national lab expenses, that may also be helpful, when you finally get this job. So if there are some of you who has no idea or no plan to do a faculty job now, you can spend several years, in industry and then return back academia. Definitely, open. Okay. And the key point is that you need to prove that you can provide what the department needs. So that's the biggest thing you need to bear in your mind. So doing this kind of academic job hunting or interviews is not only to show how good you are. More importantly, it's to show how can you make the department better. Okay. So after the academia job hunting, let's switch gear to talk about the national labs. So in United States, we have in total 17 national labs. And all the national labs are under the supervision of the US Department of Energy. And you can see the geological, allocations of different national labs. And unfortunately, we do not have any national lab, in Texas. And actually, for the 17 national labs, they can be roughly divided into 5 groups, including this kind of multi-purpose science lab, single program science labs, multi-purpose security labs, energy technology labs, and multi-purpose environment labs. And you can see from the left side to the right side, the focus of those labs will shift gradually from science to technology. Okay. And basically, so national lab, what's this legal status? A national lab is the so-called FFRDC, Federal Funded R&D Center. And even though it's called R&D Center, actually what people do here is we call that RDDD, so research, development, demonstration, and deployment. So it's unlike a university research, it's focused more on the apply side and demonstration side, because actually US DOE puts a lot of money into this kind of research stuffs and then national lab, and they want to see some kind of return of investment. They want to make something real, work 24 hours, 7 days, 24 hours one day and 7 days per week. Okay. And the good thing working at national lab is that you can have access to world-class facilities. For example, actually the 2 fastest supercomputers in the world belongs to Oak Ridge National Lab and Argonne National Labs. And actually many employees, of national labs earned Nobel Prize. And national lab career, okay, a little bit about national lab career. First thing, lab hierarchical architecture. So the minimum unit that you do business is called a group. And several groups will be combined together called a section. And several sections combined together called division. And in the end, it's the directorate. And for the latter, if you focus on I would say R&D or technology side, you will start as a postdoc, which is a temporary position, which means there is no guarantee that you can stay here. But after you pass the evaluations, you will be an R&D associate, and then R&D staff, senior staff, distinguished staff. In the end, it will be a fellow. And the pay, okay. So Ben mentioned, okay. So if you go to industry, you have a great or spectacular, payment, which I totally agree. But for national lab, since it's somehow in between academia and industry, so the pay is also in between academia and industry. For example, for postdoc, working in a national lab, the net income, per year is around 80K. I would say much higher than a postdoc in a university. Okay. And I want to emphasize a little bit. So for national labs, we rely on soft money. So that means you will be enforced to write a lot of proposals. You need to compete with other national labs for the DOT fundings. And also you need to, attract the industry partners to use your cutting-edge facilities, to make sure you can meet your personal cost. And okay, for someone who worked both in national labs and who is working in academia, I would say lab in national lab is somehow easier because you don't need to teach. But you also have, less freedom because all your research scopes is somehow fixed by the specific mission of your lab. You do not have the freedom to do whatever you want, which is really, I would say the most cherishable part of, working in a academia environment. And in addition, national lab, that means you are working indirectly for the US government. That means you will go through a lot of safety, cybersecurity, counterintelligence trainings as a national lab employees. And I mentioned, okay, some labs, they are focused on national security, like a nuclear, related technologies. So some positions may require clearance. And if you are foreign nationals, make sure to check this before you do any application. Overall procedure for national lab job hunting, much straightforward, compared to academia one. So step one, also identify suitable positions. And unlike, academia jobs, you have a predictable peak time. This kind of academia job may appear anytime. And I strongly recommend you to go to the national labs, each national labs, official career website to check the opportunities. Okay. Step two, submit documents online. So those are documents that you will need to prepare for faculty position. But for national lab, no more teaching. And the research statement, sometimes you need to prepare for that. But for the majority of times, as I know, they do not require you to submit a research statement. So cover letter, a CV plus, reference letters, very standard, very similar to an industry job. After step two, if you are selected to a Zoom or Teams interview, congratulations, you are top 3 or even top 2. And for the Teams and Zoom interview, there are 2 parts. First, you need to give an online seminar. There will be many people, join online to listen to your seminars. And after the seminar, you will have another 1-hour meeting with your group members. Okay, that means the minimum small, units or the colleagues you will work every day if you successfully join the team. And I will show an example job opening, which, just became public yesterday. Apply research for mobility system group and Oak Ridge National Lab, seeking for blah, 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 blah. And you can see for the preferred qualifications, it lists very detailed technology requirements. Why? Here it's really similar to a industry job and even more specific than industry job because they need to have someone to meet the grant needs. I already mentioned, everything here relies on soft money. They just write a proposal, submit to DOE, get it funded. And in the proposal, they already be very clear what will be delivered in the end. And they want to find someone who can meet their delivery requirements. I think that's all for my presentation today. And if you have any question, I'm here. Thank you very much.
When pick up by the mic, do you think that the academic positions, because are they more limited, or which one do you think would be easier to get a full career out of? So that's a weird way of phrasing it. Because you're doing postdoc and you have that soft funding, do you think it is easier from a sustainability standpoint to spend a ton of time trying to get that professor position first, or to go in and try to worry about soft funding and doing actual lab stuff?
So I would say, even though I mean, for whatever PhD student, if you want to join national labs, you must start from a postdoc. Depends on the sustainability of the funding of that specific group. I would say there is a quite high chance to be converted from temporal postdoc to R&D, staff in national labs. And compared to, you're doing a postdoc in a university and apply for, many possible faculty jobs, I would say actually in terms of job security, integrating international labs should be a better, option. Yeah. Yeah. Go ahead.
So you mentioned that you have, in this case, in academia, you can do like industry jobs.
Yes.
So what kind of industry jobs do you? I mean, it's like better for your transitioning from industry to academia. You cannot do any industry jobs.
Yeah, you're right. You're right. For sure. So because if your ultimate goal is to become professor,
yeah,
make sure your industry job is somehow research related. If your job is 100% writing code without any research, that's maybe a trouble.
it's kind of like the research scientist example.
Yeah, right. Research engineer or research scientist. You're right. Please.
How did your transition from the national labs?
It's a little bit personal, but okay. So two reasons. First, because my wife is in Texas. So, okay. The second point that I like teaching. Go ahead. Can you repeat the question again? I cannot hear it. Private labs. You mean university labs? Oh, private labs. I understand. Okay. So, I mean, for example, I interned at the Mitsubishi Electrical Research Lab doing my PhD. I would say for national labs, you need to understand why the United States government want to create, this kind of gigantic national labs. Because, for universities, we also have labs. Each faculty members has their own labs. But if we want to do big science, you need to have very big equipment, super expensive, cannot be afforded by a single, faculty member, or even cannot be afforded by a single university. And that's why, you need to somehow concentrate your resources to create something that you cannot do, by some, if you do not do so. If you want to do big science, have access to the cutting edge, facilities, national labs will be a very good option for you. But the bad side, as I mentioned, since you are working indirectly as a US government employee, you have many rules, you have many kind of constraints, and you do not have many freedoms. For example, if you are working on some kind of nuclear or aerospace, related technologies, if you want to publish a paper, maybe there is a big no, you cannot do that. Great, thank you.